Hello everyone, I'm Gokulnath.P. I'm a data science intern at the Sparks Foundation. My second task is to predict the optimum number of clusters and represent it visually using unsupervised machine learning. So I've used Python for this task. Let's see how it is done. So our task is to predict the optimum number of clusters from the iris dataset and represent it visually. So since iris dataset is a global dataset, we can import it directly. First, we are importing the libraries of NumPy, Matplot, Panda, and sklearn. So we'll see why these things are used in the following groups. First, we'll load the iris dataset by loading the iris dataset into iris, and then we are creating a data frame, iris df, and we are uploading all the data from iris and creating a data frame to that. This contains only the columns which has the iris features, which means we are excluding the species name column. And then we are using the head function to represent the first 5 rows of the newly created data frame. So you can see we have excluded the species name here and we have represented only the first 5 rows. Okay. Now our task is to find the optimum number of clusters for k-means and to determine the value of k. For that, we are assigning the variable x with the locations of the first, second, third and fourth column with the help of indexing, which is 0, 1, 2, 3. And then from sklearn cluster, we are importing the k-means function. And WCSS is within cluster the sum of squares. This is used to find the sum of the squares along with the observations. So to find the k-means, we are putting it in a for loop with the range of 1 to 11, since we do not know the definite range, and we are assigning it to the variable called k-means, and we are using the k-means function and initializing the n clusters like I and k-means k plus plus using constructive iteration. Then we are fitting the x in the k-means and we are appending the WCSS. So after this, we are plotting the results onto a line graph to observe the elbow. Let's see what the elbow is. So as before, we are keeping the range as 1 to 11 and we are plotting the WCSS, and the title is the elbow method, number of clusters, sum of squares within the cluster, and we are showing the plot here. As you can see, there is a very significant decline in the graph till 2, and this is quite significant. And after 3, the decline is insignificant. It is the decrease is not significant at all. So from this we can clearly say that the number of clusters is 3. So this is the elbow method, wherein you can see a clear elbow at 3. So from this we are concluding that the number of clusters is 3. But our task didn't end at that point. We have to visualize the number of clusters, right? So again we are using the k-means function to the data set, and then we are fitting it in the variable called y k-means, and then using the scatter plots, we are using the green color for iris setosa species, and for pink for iris versicolor, and yellow for iris virginica. And we are plotting the centroids of the clusters also. So for that we are using the black color. And plt dot legend, this function is used to show this box which color is assigned for which label. So yeah, so now we can see, like, we have visualized all the clusters of all the 3 species here, and hence we are concluding that the number of clusters is 3, and this is the visualization of the type of iris flash. Thank you.